For today, we're going to look at the confidence interval for our matched pairs, meaning the differences between two data. So, if you want to do this by hand, there's your formula. So when the conditions are met to match our data sets, we are ready to find the confidence interval for the means of the pair differences. The confidence interval is same thing it's always been, where it's your mean plus or minus your degrees of freedom times the standard error. Where the standard error for the mean difference is this, where you have your standard deviation over the square root of your n, total number. Now, making confidence intervals for matched pairs follows exactly the same steps as a one sample t interval. Now, how is that possible if we're dealing with two different data sets? It's because we're looking at the what? What was our keyword yesterday? Difference. So because we only want to look at the data that is the difference between the two, then we are dealing with just one set of data. For example, in developed countries, the average of women is generally higher than that of men. But if we look at the married couples, husbands tend to be slightly older than wives. Given a random sample of 200 British couples, 170 of whom provided both ages, create a 90% confidence interval for how big of a difference there is on average between the ages of husbands and wives. So we have our data set here, we had our wives, we had our husbands, but the most important part would be this part right here, right? This is what we want to focus on, the difference between husbands and wives. So I had to take 43, subtract from 49, I get 6. 28 minus 25, negative 3. So I'm taking 25 minus 23, so I'm going the opposite direction. Husbands minus wives. So 49 minus 43 is 6, 25 minus 28 is negative 3, and so forth. So I'm going this way while subtracting. And I end up with this as my difference table. Now let's look. Let's look at our certain conditions. Does this meet independence? Would you think this satisfies the independence? I think the woman's age is independent from the husband's age. I think that'll work. What about the pair data? Do you think this works with the pair data condition? Sure. Well, don't we have our husbands and wives paired up? Yeah. Or looking at the difference of the two? Yes. So that meets that one. What about our randomization? I'm taking what? Random samples, right? So that works out. And one more. Do I have a nearly normal model in regards to the differences? I don't care about the normal model of the husband or the wives. I want to look at this normal model. And it looks pretty close. I do see a couple outliers here. If I were to write up a report, I would make special note of that. Maybe see what my data looks like first to see if I want to take those out or not. But for now, we can say this is pretty close or close enough. So I'm given that my n is 170. My mean of my difference is 2.2 years, and my standard deviation of my difference is 4.1. Now remember I said this works exactly like one sample. So we'll go to our calculator, and we want to go to stats, test. Anybody remember which test do you test for a confidence interval?
No.
Of one sample with means, with t-test?
5. No.
Proportion, no, that's going to be our categorical data. We're not going to be working with two samples. Well, we are, but we want to focus on the differences of one sample. So t interval, just that one. I want to go over to stats and plug in my information. So my mean that was given, 2.2. My standard deviation was 4.1. And my N was 170 couples. Now note, I sampled 200 couples, but only 170 provided information from both the male and female. So I only want to look at that 170. Does that make sense? Yeah. I only want to look at the data that I can pair together. And I want a 95% confidence interval. So 0.95. And calculate. So this tells me that my confidence interval is between 1.57, or let's just say 1.6 and 2.8. What is this exactly telling me? Somebody interpret this. I'm taking the difference from men to women, and I'm 95% confidence that what?
It's between the differences between those two values.
Okay. Who's greater?
Men.
Men, because I'm doing men and women, right? So if I'm getting positive numbers here, since men is my leading variable, that means that I believe 95% of the time on average, men are between 1.6 and 2.8 years older than women, as far as couples are concerned. Or sorry, as far as husbands and wives. So, it's going to work the exact same as if we just had one. Because with paired data, keyword there. Can't say it more often than not. Differences. We just want to focus on the difference. Now, if we were in stat L, this is pretty much where we probably would stop, where we're given the difference information. Well, what if you're not? Because this is AP stats. What if you're just given, hey, here's some information, go and find the paired data confidence interval. So, the accompanying table gives the average high temperatures in January and July for several cities in a certain continent. Write a 90% confidence interval for the mean temperature differences between summer and winter on that continent. Be sure to check the conditions for inference and clearly explain what the interval means. Let's go ahead and assume that all the conditions meet. Let's check the differences. So what would you do? Would you type in both of these into your stat edit? Would you type these both in your stat edit and try to calculate it? What are we more focused on with paired data? The difference. So let me go ahead, since I am comparing January to July, or sorry, be sure to check. Let's compare, we could go, which way you want to go? You want to test January to July or July to January?
July.
Okay, so we're going to go this way, which means what's the difference between 75 and 35? May want to grab your calculator out to help us.
40.
40. So note, I am making my difference table. Again, we got to do things by scratch sometimes. What's my difference between 73 and 35? 38. 75 and 41? 34. 75 and 35? 40. 90 and 54?
Yeah, 40. Yeah, 40. No.
46? Thank you. 36? Oh, sorry. 36. This is why it's always good in stat to have somebody check your work. 88 and 54? What's that? 34. 70 and 41? 29. 88 and 47? 41. 73 and 43? 30. 64 and 44? 20. 77 and 22?
55.
55. And then 85 and 36. 49. So here in the red is the table I want to focus on. The difference between July and January. This is what I want to plug into my calculator. So go to Stat Edit and plug in these values. Now let me look at the histogram, just so I can make sure it's a nearly normal model. Let me put my plot on, type, bar graph, blue, let me graph. Let me zoom stats, so number 9, and looks a little skewed, but we'll play with this. We'll go ahead and say okay, I'll say this is near the normal model, but something I may have to justify later. Depends on my results. So now let's go to stats, test. Again, we want a 1t interval as we're testing just the difference. Now that I have data that I plugged in, we'll go to data. L1 confidence interval was 90 and calculates. So my difference was comparing July to January. So what does this confidence interval mean? I'm 95% sure that what is going to happen. July is going to be more than January, but by how much? Yeah. So this is giving my range. I'm 90% sure that July is between 32 and 42 degrees warmer than January. That's what this data is telling me.